I welcome everyone to this video. I am Mr. Ish. I hope everyone's doing well. A chemistry question. Now let's look at this. It's going to be fun. We have a 2 molar salt solution, sodium chloride. It undergoes a volume change from 5 liters to 3 liters. We have to find the final pressure. Think about what's going on. We have a solution here which is 2 molars. We'll just write 2 molar salt. You basically have a piston on this and it's pushing down. It's going to go from an initial 5 liters, and when you compress it down, you're going to bring it down to 3 liters volume, and the system will be over here. You'll have that, and you're seeing here a 2 molar salt solution. What is the final pressure? We have initial pressure, initial volume. We have a final pressure, final volume. What are these items? What's our initial pressure? We don't know. What's our initial volume? It is 5 liters. What's our final pressure? We have to find it. And what's our final volume? We know that to be 3 liters. How can we go about doing this, especially when the pressure is not provided? So this is the part where we have a little bit of a fun. Now look, think about ideal gas law and think about molarity. You know molarity is the concentration of a solution. Molarity is always equal to moles over volume. You solve for moles is equal to molarity times volume. Now think about your ideal gas equation. PV is equal to nRT. You substitute this item right over here. I have PV is equal to molarity times volume times R and T, your ideal gas constant and temperature. You know you can cancel the volumes, so now I'm suddenly looking at P is equal to, your pressure is equal to molarity times R and T. Things become easy now. I'll tell you why. You are familiar with the equation P1 V1 or P initial V initial is equal to P final V final. Well, now we have this. This right here is equal to my pressure initial, which is equal to all of this initial. You bring it in. I have molarity times R and T, initial conditions, times your initial volume is equal to all of this, your final pressure, which will be molarity, rate constant, and temperature final, and volume final. You know R and T are constants. You could essentially remove them. You are in essence looking at molarity initial times final initial is equal to molarity final and volume final, and suddenly this becomes our equation we can use. Let's proceed here. What we're going to determine now is the final molarity, because that will clue us into the final pressure. Look, I have an initial molarity here to be 2. I have an initial volume, you know that's 5. I have here a final molarity. I don't know what that is. We'll figure it out. When you're putting pressure on a solution that's not very concentrated and you condense it into a smaller volume, you make it more concentrated, because now you have in essence the same amount of solute but is being pushed into a smaller volume, hence the concentration goes up. This right here is my final molarity, and you have a final volume to be equal to 3. You know your final molarity is equal to 10 over 3. Now what do? I know pressure final is equal to molarity final and RT. I know I have now pressure final is equal to 10 over 3, which is my final molarity coming in, times R and T, and we use this. How can we use this? You just have to plug in the values of R and T. You know we're basically looking for this, and we will do it. The initial pressure here was irrelevant. You didn't even need it. You'll do rate constant, which is 0.0821, temperature 273 Kelvin, and let's determine the final pressure. Let's bring out our calculator. I have here the R, the rate constant, 0.0821. I have the temperature 273 Kelvin times the final molarity 10 over 3, and I'm dividing it by 3. I have 74.7 atmospheres. That right there will be our answer. 74.7 atmospheres. You needed that much of a pressure to condense a concentrated salt solution from 5 to 3 liters. From 5 liters to 3 liters, it required a significant amount of pressure, and that pressure was 74.7 atmospheres, and it will represent the final pressure of the system. And that's it for this video. Thank you for watching.